All right, let's talk about something that's, well, it's everywhere, but you can't see it. It's this kind of invisible science that is the engine behind our entire digital world. I'm talking about why your phone calls work, why your Netflix streams without buffering, and how your emails just appear. It's called information theory, and it totally and quietly changed everything.
But to really get a handle on it, let's start with a little mystery. We've all been there, right? You find an old CD, it's covered in scratches and fingerprints. You think, there's no way this is going to work. You pop it in, and it plays. Perfectly, not a single skip. How is that possible? It seems like all that data should be ruined.
Well, believe it or not, the secret behind that scratch CD is the exact same principle that lets us do some of the most amazing things imaginable. We're talking about communicating through the noisiest environments you can think of, from a choppy cell signal in a basement to the vast, static-filled emptiness of deep space. We figured out how to send a perfect message through a very, very imperfect world. So to get to the bottom of this, we've got to go back in time. Back to the middle of the 20th century, when some of the most brilliant minds were banging their heads against the wall over one fundamental problem. How do you reliably send a message from point A to point B when the journey is just full of interference? Now, the idea wasn't totally out of the blue. Guys like Harry Nyquist and Ralph Hartley were already poking at this, trying to figure out how to measure this fuzzy thing called information. But then, in 1948, this lone genius at Bell Labs, a guy named Claude Shannon, came along and connected all the dots with a single groundbreaking paper that created an entirely new field of science overnight. Shannon laid out the problem with this beautiful, simple clarity. But he realized that to solve that problem, he first had to answer a much, much deeper one. Before you can reliably send information, you have to be able to define what information even is. And this, right here, this led to the core concept that changed everything. An idea so powerful and so elegant that it became the literal bedrock of the digital age. Okay, so forget everything you think information means. For Shannon, it had nothing to do with facts or meaning. Information was simply the resolution of uncertainty. That's it. The more surprise, the more uncertainty you clear up, the more information you've just received. This was the first time anyone had ever put it into a solid mathematical form. Now, that sounds a little abstract, I know. So let's make it super simple. Imagine a coin flip. Before the flip, there are two possibilities, right? Heads or tails. There's some uncertainty. Now, think about rolling a standard die. Suddenly there are 6 possibilities. Way more uncertainty. So, finding out the result of the die roll actually gives you more information than finding out the result of the coin flip, simply because it resolved more uncertainty.
And this measure of uncertainty needed a name. Shannon borrowed a term from physics, entropy. In his world, high entropy means lots of uncertainty and therefore a high potential for information. Low entropy means something is predictable, so learning the outcome doesn't really tell you much that's new. And he gave us the perfect unit to measure it, one single bit. A bit is the amount of information it takes to resolve the uncertainty of a fair coin flip. It's the answer to one simple 50-50 yes or no question. That little concept? It's basically the atom of our entire digital universe. So once Shannon gave us this amazing tool, a way to actually define and measure information in bits, we could finally start to manage it, to control it. And that led us straight to the solution for sending perfect messages through all that noise. This is where something called coding theory comes in, and it's brilliant. It basically splits into 2 big ideas. On one hand, you have source coding. Think of that as data compression, like making a zip file. It's all about stripping out redundancy to make the message as small and efficient as possible. But then you have channel coding, and this is the really clever part. It does the exact opposite. It adds redundancy back in, but a very specific, very smart kind of redundancy that acts like a shield for your data. So here's how it works in practice. Your original message gets encoded. Then it gets sent out into the wild. That's the noisy channel, like the scratch on the CD or a weak Wi-Fi signal. On the other end, a decoder is waiting. And it uses that extra smart redundancy to spot any errors that happened along the way and, like a puzzle, piece the original message back together perfectly. And there it is. That is the solution to our original mystery. That CD isn't playing because the laser is somehow dodging the scratches. It's playing because the music was encoded with these error-correcting codes. It lets the player literally rebuild the missing bits of the song on the fly. It's not magic, it's just really, really cool math.
But the story doesn't stop with CDs and phone calls. Not even close. The truly mind-bending part of information theory is just how far its branches have reached. It's kind of become a theory of everything. Shannon's work is the direct mathematical backbone for just about every piece of modern tech. Getting those crystal clear pictures from the Voyager probes way out past Pluto, that's channel coding. The invention of the CD itself, based on error correction. Mobile phones, the internet, all of it. Every last bit of it is built on, well, the bit.
But here's where it gets really wild. The theory was so fundamental that it just escaped the engineering labs and started showing up everywhere. I mean, artificial intelligence is all about reducing uncertainty. Cryptography is a constant war over information. But then scientists started using it to understand the firing of neurons in our brains and the physics of black holes, even our own DNA. So what Shannon gave us wasn't just a way to build better phones. He gave us a completely new language to describe reality itself. It turns out that information might not just be something we create. It might be one of the fundamental ingredients of the universe, from our own genetic code all the way up to the cosmos. And that's really the big idea here. We started with a simple scratched CD, and we ended up at the fundamental nature of reality. It really makes you wonder, doesn't it? If information is truly the code that runs our world, what other profound secrets are just sitting out there, waiting for us to finally decode them?